Okay, it is 11:40. I'm going to begin. Some people are going to come in, might leave, that's okay. And since all of you have exceptionally exquisite taste in talk selection, I would like to ask you all a question. Who here is familiar with Azure Functions? Raise your hand. Okay. And who here has created one, either playing around, actually has some in production? It's a good amount, okay. That is a great number, excellent. So when we think about Azure Functions, as I'm sure you all know, the ones who have created ones, these are really, really great solutions for things that are small. Things that are small pieces of code, just a single action that we need to do, something that doesn't need a full-blown infrastructure for it. And when we think about functions and how we got onto that journey to get there, or to even start thinking about using functions, it usually goes along the lines of this kind of thinking. You know, you're talking with your team, you're sprint planning, maybe you're talking with your colleagues about how you can improve your platform or how you can get rid of this one legacy bit. And usually the talk goes like this. Well, I just need to do some small event-based task, insert there, your choice. But I don't want to provision any resources first. It's going to be too costly. It's going to be too time-consuming. We don't need an entire full-blown infrastructure to do this backup of a file or to do this resizing of a photo. That's just overkill. But if we actually needed to scale that, we need to be able to also dynamically scale that if, for whatever reason, our application needed to. Oh, and by the way, I only want to pay for the compute resources that I actually use. Behold Azure Functions. That's what we use them for, right? We want something small but flexible, something where we only pay for what we use, and something that, if need be, for different kinds of scenarios, especially in situations where we don't know what that kind of scaling need is going to be, these are great. They fill that need. So what are durable functions? Durable functions are a library that extend Azure Functions. And they do that by allowing us to create stateful workflows. Stateful workflows are given to us as developers if we have something called workflow orchestration. But that's something that's very, very difficult to do in regular Azure Functions. So durable functions, all that jargon, all that workflow orchestration, all that stuff, all that really means is durable functions fills in the gaps where Azure Functions fall short. So what does this mean? How do they fill in those gaps? What are those gaps? So for durable functions, what we use them for is for a code-first style of development for workflows. If we have long-running workflows, if we have sequential workflows that have dependent steps, if we have very complex workflows that branch off into very many decision trees, those are the kinds of workflows that we're thinking about and talking about implementing when we talk about or where we need workflow orchestrations. These are things that are difficult to implement in regular Azure Functions. You can do them, but they're very difficult. Durable functions also are stateful. And if there's one thing we've ever been told about functions and serverless, it's that keep it small, keep it quick, because every time that's running, our bill is also going higher. So we want to keep it small, keep it long running, have it do its job, and have it shut down very, very quickly. Which means we can't really have state in those kinds of functions. And sometimes the complex workflows that we have, we need state. If we have longer workflows where we're, say, getting information from a lot of different sources, if we're getting information from a longer period of time, we might need to keep some kind of state in order for us to do that kind of processing. And lastly, durable functions are consolidated. So again, you can try to implement these workflows in regular Azure Functions, but these may be piecemeal, especially if you're doing some sort of microservice architecture, and each microservice is a function, if you're lucky enough to get it that way. But as you might have noticed, if you're trying to debug these things and they're not in a single place, you might have functions that are semi-related, but even if you have great logging, it's still really hard to kind of pinpoint which part of your process actually failed. What happened? Can you actually roll back those things if they did go wrong? Those kinds of things are very difficult to do in regular Azure functions. So durable functions are filling those needs. Durable functions are what allow us to do this, as it's built on top of regular Azure functions. Now, how does it do that? I'm glad you asked, because there are 4 different kinds of function types that most durable functions are composed out of. And these are very imperative to understand. You might have worked with them before. If you've used Azure Functions, you might already be familiar with these, but it's very good to get that ground foundation before we move into the patterns so that you can see how beneficial they are. So the first function that most or all durable functions are composed of are called client functions. What are client functions? Well, client functions are what we call the entry point functions. They are what kickstart our orchestration. They are usually invoked by a client, a user. Someone makes a call to our client function, and this is what kickstarts the new orchestration instance. They're just like regular functions, except they have a super special durable client output binding, and that binding is very, very important. It's important because it's that binding that allows us to trigger something that we're going to talk about next, which are orchestration functions. And it's also very important because that's what allows us to interact with the running orchestrations that we have. So the client function is the thing that starts it all. This is where if we need to do a long-running workflow, if we have a long sequential thing, something needs to start it. And so client functions are also usually known as starter functions. And as an example here, we have a very simple client function here. So in my client function, we have an HTTP trigger. So they're like regular functions. They use the same events that Azure functions get triggered by. So blob storage trigger, timer triggers. In this case, mine is an HTTP trigger. So whenever a client calls this, we also have our durable client starter here, and this client is what enables us to start our actual orchestration function here on line 47. So this gets called, we start a new async instance of an orchestration function, we get an ID back, we have some logging, and then we return something that's a little bit different, and we'll get to it. But for now, all you need to know is that it's an HTTP response message that allows the client to continuously check on the status of our orchestration. And that's very, very neat, and you'll see why in a second. So that's the client function. For our durable function, we've started it, and the next thing we need to do is go to the actual orchestration. So the orchestrator function. Just as the name implies, the orchestrator function, it's the heart and soul of durable functions. This is what tells all of our processing tasks and all of the steps in our workflow. This is what is used in the outline. So this is where you start defining the order of the steps. This is where you start defining the crazy branches and decision trees that you may need for that particular process. This is where you can put error handling and exception handling. These are all of these things that are so difficult and very cumbersome to do in Azure Functions. You can do them here in this orchestrator function. And so to continue with the example that I have here, our previous client function, when it started and created a new instance of our orchestrator function, this is that function. And when it creates that new instance, it creates the definition of what we're about to do. So in this case, mine is very, very simple at this point for demonstration purposes and just to talk about it for now. But in my orchestrator function, all I'm simply doing is, this is actually called a proper greeting for London function app. So instead of, hello Seattle, hello Tokyo, I changed it to what I think would be appropriate. So I'm saying hello to proper etiquette because I know there's a lot of people in America who don't have it. You too have it. You too have it. Hello, Your Majesty, right? We're in London. And hello, London. And what this orchestrator function does is that it calls each and every one of those tasks, and it tells it to do something. It tells it to go do that task. And if it were a little bit more complicated, we can have some decisions made. But for the sake of simplicity, I am simply calling that activity function, whatever it does. I'm getting the result back, and I am simply outputting the returned results of those activities. So that's our orchestrator function. But at this point, we actually haven't been doing any work at all. We have kickstarted the orchestration instance, and we know what steps we have to do. We know what we have to do in our long workflow, but the work is not actually being done at this point. When it is done, though, is in these things called activity functions. So activity functions are the actual tasks, right? These are the execution of what you have seeked out to do. And again, these are like regular Azure functions, but they can only be triggered by an activity trigger. So that means you can't use the regular event-based things that you use to trigger Azure functions, or regular functions, rather. They can accept an input parameter from the orchestrator function. So what that means is, you saw before I had Your Majesty, I had proper etiquette, and London. All of these are the inputs that are passed to my activity function, and then in my activity function, I do something with it. I process it. In this case, I am simply appending a kumusta. Kumusta is hello in Tagalog. And after I get each name, or thing in this case, I just append a kumusta and return it back. The great thing about this is that if it needs further processing, it can do that. If what is done here, which is just appending the kumusta, is just one part of a larger sequence of things that you need to do, you can do that in this one activity function, return the result to the orchestrator function, make a decision, and then call the next required activity function to do further processing. This is not a one and done deal. Activity functions are very important here, and they're important in the sense that to really gain the benefits of durable functions, you want to try to keep them small. Kind of like microservices, but the only things that are quite related is that if you try to keep them as a single responsibility task, you'll have a much better chance of scaling the parts that you need to and actually be able to put them in different places. I like to call it the Lego factor. If you can make it such that they can be used like Legos, then you have a really good activity function. So out of all these functions, the client, the orchestrator, and the activity function, these are the three that you'll most likely see whenever you work with durable functions. These are all you would really need if you needed to create a long-running workflow, or a sequential workflow, or any type of complex long-running stateful workflow. But recently, they just released something called an entity function. Now, entity functions are kind of similar to orchestrator functions in that where orchestrator functions define the number of steps or what steps are about to be done and what kind of processing needs to be done, entity functions define the operations for reading and updating certain pieces of state. So here, we're extending that even further. If you need fine-grained state management, you would probably want to use entity functions. Now, entity functions are like activity functions in that they can only be triggered by an entity trigger. And this is the only kind of function that actually manages state explicitly. So you're all thinking, that's great, Adrienne. 4 functions, I've seen them before, or they seem pretty self-explanatory. I can kind of see how the pieces fit. But what's actually happening? What is going on when we actually call these functions? And if you remember the example that I gave earlier about appending a kumusta to all the different places that I want to, or things that I want to say hello to in Tagalog, at this point, we kind of understand what is happening? The client function has been invoked, which means it's kickstarted our orchestration. And then a new orchestration instance has been created. We got an ID back. So at that moment that we're now in the orchestration function, what is happening? Well, once we hit that very first call to the very first activity function, that first await.call async activity, what happens is that the orchestrator schedules a queue message and sends it to the activity. It does so in its own internal queue. And when it does this, it's funny, but the orchestrator stops. And that is very, very interesting, because if you know Azure Functions, the longer running it is, the higher your bill is. And if you have some potentially long processes that takes very, very long, or you don't know how long it's going to take, those function prices are going to keep skyrocketing up. In this case, though, you are only billed by the orchestrator function. You're not billed by how long the activity function is running. This is why we try to recommend developers to put any of these kinds of processes in the activity function rather than the orchestrator function. So the orchestrator stops. Meanwhile, the activity function is doing its job. And when the activity function is finished and it's done doing whatever it's supposed to be, in my case, it was just appending a kamusta, but it could be way longer. When it's done, the activity function then serializes that result. It sends another queue message back to the orchestrator, and the orchestrator receives it. But remember, the orchestrator is now stopped at this point. It's slacking off. It's sleeping on the job. So once this queue message is returned to the orchestrator, not that, but it wakes up the orchestrator function. It says, hey, we have some stuff to do here. So by the activity function sending that new queue message with the result, we wake up that orchestrator. And then an even more interesting thing happens. So when the orchestrator function restarts, it restarts from the first line of our orchestrator function. And when it starts at this first line, we now have the result back, right? We got the queue message from the activity function. So that result is stored. And that's very, very important. Because this is now stored, what happens next is that our orchestrator completely loads a full history of this particular instance's execution history. So every time a queue message is scheduled and says, hey, I need to do an activity, hey, I received an activity, hey, this thing has been scheduled, hey, this thing has been completed. All of those things are logged in a table, in an Azure. That's why you need an Azure storage account when you create a durable function. It's because it needs a place to store all of these events. And it does so in an event sourcing pattern, which means it only appends events. This makes it very reliable, this makes it very resilient, and this makes it possible for us to understand where things may have failed. It makes it easier for us to debug what may have gone wrong in our process. It helps us really pinpoint what is going on in each step of our orchestration. And so once it reloads this entire history, and then it starts going through the different lines in my function, my orchestrator function, it then has to decide, do I send another activity function because we're still on the first line? Or do I move on to the next activity function? It's able to decide this because at the point that it has to decide, it reads it and it says, hey, I already have a result here for my first activity. This means I don't need to schedule another queue message to that particular activity function. So that means I can move on to the second activity function. And we can double check that in our event history, because when we look and see, hey, there's nothing for the second activity function, we don't have a result here, I need to schedule something. I need to send that over. So this keeps going, and it keeps repeating, and the orchestrator keeps stopping every time it sends a message and waits for it to be woken up again. And it repeats it for as many activities that you call. So if you're thinking about how this is functioning, how it restarts at the first line every single time we get back to our orchestrator function, it has this kind of replay functionality. And that's very interesting. It's very powerful, but it also means that there's some rules about how we have to write our orchestrator function. And there's a nice big word that we like to use. This means we have to make deterministic orchestrators. So what does deterministic mean? Well, deterministic things, or in this case, deterministic functions, are things that no matter how many times we call it, and no matter when, if we give something a specific input, we need to expect that same exact output every single time. Bless you. So that is the sign of a deterministic function. It needs to be the same result every single time. And if you think about it, with the way that it restarts from the very beginning and does everything over and over again, if we have something that's non-deterministic, that can be very problematic for our orchestration. Bless you again. If we have something that's non-deterministic, that could throw off the actual state of our orchestration. That means that, let's say that first variable, we did get a result back, but we used something non-deterministic in our orchestrator function that caused that to change, or that caused that to maybe not exist. Well, the orchestrator wouldn't know that, so it's going to think, hey, I need to send another message again. That can lead to many catastrophic effects for our orchestration. So we don't want that. So I took it upon myself to tell you how to create deterministic orchestrators in a single meme. I hope you can see this. So the foundling says, please don't use datetime.now, because that is non-deterministic. That's going to be different every single time you use that. Please don't use anything random, nothing random, random numbers, random GUID generators, random UUID generators. Again, unless they're safe, which you can't really guarantee, it's going to be a different result every single time you call that, which makes it non-deterministic. Don't use multi-threading. This entire premise is built on a single thread. So if you use multi-threading, that's obviously going against it, but it's probably not going to work, and it's going to affect the result of your orchestration. And async API calls. There's a whole other list, and I'll probably send it out with a list of resources that I've used to research for my talk. But Microsoft has a great table about what to use and what not to use. And really, if you think about it and you read this whole table, what it essentially ends up amounting to is use current UTC datetime if you need to, and everything else that you're pretty much thinking about doing, put it in an activity function, because it's not going to belong in the orchestrator function. So why durable functions? I've told you how they're composed, I told you how they work under the hood, and I told you about some of the key differences of why you would use them over Azure Functions. But I'll tell you 3 more reasons why that are a little bit more developer experience focused. So to start, they're simpler. As I showed you earlier, that orchestrator function can list out the full details of what our orchestration will do. This comes with a lot of built-in code that you don't have to do. You don't have to manage statuses, you don't have to manage checkpoints, you don't have to find a way to keep track of what's happening, especially for long-running orchestrations. You don't have to write that code, because the Azure Durable Function library has already done that for you. In this way, you remove a lot of that code, and you can focus on the actual workflow that you're trying to do. Simpler also means multiple functions, smaller functions, activity functions. And when you can strive to get there to actually make those activity functions single responsibility, you have an easier time to be able to scale your workflow. If only a particular piece needed to scale further, you can do that because you've created an activity function that only deals with that specific thing. This is not to say that, when you start thinking about migrating a workflow, you're not going to have some super admin activity function where you just take 300 lines of code and put it in that activity function. That's not what that means. It means you need to re-architect it, you need to think about it, and you need to try to make it into smaller, manageable chunks. This way you gain the benefits of it being simpler. Stateful is a big, big thing about durable functions. I've alluded to it earlier, but again, it keeps track of every single step that is done, something that you don't have to do. And in especially long-running complex scenarios, and in some of the patterns that I'm going to show you in a bit, these are key for you to be able to do some of these patterns. If you try to establish or implement this in regular Azure Functions, again, it's a lot more code that you have to write, And if you try to use regular Azure functions, they're not supposed to be stateful by design. And lastly, scalable. So again, it's the Lego factor. If you're able to create these pieces in a way that you can mix and match them, then your orchestrations are going to be a lot easier to scale. So we're now here, we've laid the groundwork for what durable functions are, what they're composed of, and how they work. So now I'll show you a few of the patterns that we can use to actually implement some of these long-running complex workflows in a much simpler fashion. So there's 6 of them. And the first one is called function chaining. So the name itself sounds like you can understand what it means. But the function chaining pattern is essentially, it's sequential. So you have a set of functions, and usually the output of one function is the input of the next one. And that sounds familiar, right? It sounds like the pipe operator. That's what I thought of when I first learned about this pattern. So a really cool thing here that is not working. Oh, it is working, awesome. So this could be thought of as a function chain. Does anyone know what that is? Who said that? Yep. Excellent. That is a Filipino egg roll. I'm Filipino, so don't worry. You don't have to worry about what ethnicity I am anymore. I'm Filipino. And this can be modeled as a function chain. There's a specific step that you have to do to create these Filipino foods. So it's like an egg roll. You can put some vegetables, some meat in it, roll it up, seal it with egg wash, and fry those suckers. And they're delicious. And so we can actually model that into a function. So I have a bag of functions here, and I've created a lumpia chain here. So this is an example of how you could implement this as a function chaining pattern. So I have a lumpia assembly chain here. Make this a little larger, if it will. Okay. So you'll see here already I can use a try-catch block in my orchestrator function. And for each step that I'm about to do, I am waiting for a new output of what I'm doing at each step of my lumpia making. So the first one is I have just a plain wrapper and some filling, right? So what I want to do is I want to create and start and call an activity function called scoop filling onto wrapper. And the resulting output of that function is a wrapper with some filling on it, much like that first picture that you saw. Now we take this potential lumpia, because it's still not ready yet, and we're going to pass it on to our next one, which is the fold and roll. So after folding and rolling that output, we now result in the rolled lumpia, right? And again, we keep going and forward. The next step is we now take the rolled lumpia, which is the output of the fold and roll activity function, and we input it into the add egg white seal function. And then we call that last function there to actually essentially fry those egg rolls. And that's what frying it does. That's the last one. They're delicious, you should try them. They're different from any other egg rolls you've tasted. So the second one, the second pattern that we have is called fan out, fan in. And this pattern is, again, fairly similar. You can do this in regular functions, but it's going to be very, very difficult to do the second part of this pattern in regular functions. So for fan out, fan in pattern, what we do is we have multiple functions that are executed in parallel. So this works well, it's my German accent there. This works very well for things that can be broken down into manageable chunks that can be worked on independently. And that sounds very much like what we actually did with the lumpia. But knowing Filipinos and knowing Filipino families, one person making lumpia is not going to be enough for the size of Filipino families that usually come to our parties. So what we want to do is enlist the help of many titas. Titas are ants in Tagalog. And so for this fan-out, fan-in pattern, I want to get the help of some of my titas, my ants, to start actually making more lumpias. And then at the very end, the collective amount of lumpias that are made, we now have a much larger amount, and we certainly have enough to fry for everybody that's coming to the party. So again, I've modeled this in a lumpia fan-out, fan-in chain. And I have a tita's fan-out, fan-in function. So again, this is modeling what the orchestrator would look like. And this is very simple. The fanning out part is very simple. You can do that in Azure Functions. Where it becomes very difficult is the fanning in part. How do you correlate the ones that are actually related to each other in regular functions without keeping some sort of state? Well, if you do that in durable functions, it's very much as simple as calling the task.whenAll. So as each theta is given and assigned a task of that particular activity function, say making the lumpia, once each person is done creating that lumpia, we aggregate the final sum of all the lumpia rolls that we have now made, and then we can finally fry those suckers. So what does that look like? That means I have a Tita Cheryl, a Tita Marovic, a Tita Angelique, and a Tita Andy. And by enlisting their help and by having them create a lot more lumpias, we can all collectively together create way more and then fry the newer, larger amount of lumpias. So the third pattern here is the Async HTTP API pattern. That is a mouthful. So this is also known as the polling consumer pattern. So when a client calls an HTTP API, much like the very first example I showed you, instead of sending a direct result, we send them a 202, which means it's accepted, it's still processing, it's not done yet. And we send them some URLs to be able to check the status of what we're doing. And when I thought of this pattern, I was thinking about what are things that could take a very, very long time, because that's what this pattern is good for. Sometimes you have an asynchronous API call that kicks off something that takes forever. And I knew exactly what takes forever. When I was younger, most Asian families are very strict. Mine was no exception. And I lived in Florida, in a not nice part of Florida. And my high school was about an hour away from where I lived. And we were okay. We weren't poor, but I did not have a car, so I couldn't drive myself to anything, which means my social life was completely terrible when I was a teenager. But anytime there was a party going on in my high school, I would try. I would certainly try to ask my mom to see if I can go, because the only way I'd be able to get there is if my mom would drop me off and drive me there, an hour, maybe sometimes more, to get to that place. And usually when I would initiate this process of making sure she's primed and in the best situation for her to say yes, I'm usually left waiting, hoping for the right moment that she's going to say yes. And so for the Async HTTP API demo, we're going to do the asking my mom to go to a party in high school demo. So I have a party request here. And it's going to start as normal. But what's happening here is I have my orchestration function here. And what's happening here is I'm going to call one activity function called askMom. It's essentially just asking her, hey, Mom, can I please go to this party? And when we look at my actual activity function, you'll see here that, again, it's very similar to what we did earlier, but I'm essentially asking, Mom, can I go? And if it's the second or the third try, I'm going to ask with the extra incentive to hopefully make her say yes. And we'll see this in a second. I added an artificial delay here so that we can see it going. But essentially, after I ask it every single time, it just gets worse and worse and worse. And she eventually just says no, up to the point where she's very, very angry at me. So we're going to start this. I hope I can do this fast enough. So this is the function that's running. We have started this. So at this point, it has instantiated all of my orchestrators. It has some of the other ones that I have here. The one that we're interested in is the HTTP request, party request. And so I'm going to take this particular endpoint, and we're going to start this orchestration. We're going to start the process of asking my mom if I can go to this party. So we are going to do that. And you'll see here that this is exactly what that means. We got a 202. It's accepted, it's processing, it's running. And remember, I added that artificial delay there, so it's going to take a little bit longer. But what this means is that now I have these particular URLs to go check and see how am I doing on the status of being able to go to this party. Let's see if this goes through. I'll click the right one, status. Yeah. This might take a little longer, unless the demo gods are not going to bless me today. Let's see if there's an issue. So it did execute the get. It is asking mom. And you'll see it's asking mom now, can I go to this party? And it's not working. Let's see. On the fly debugging. We'll see what's happening here.
Is it still in the delay?
I don't think so. Delay was only 1,500. Well, this is very indicative because it's not going to happen anyway. So what ends up happening, and this is another cool part, is that we can actually see what's happening here by going into my Azure Storage Explorer, if I can find this. So right now, because I'm developing locally, I'm using an Azure Storage emulator, so I don't have an actual account connected yet. But I apologize, this is kind of small. But you'll see here that it does keep track of every single thing here. And that's what we were supposed to get. So on the third one, she's getting really agitated, abort. Abort asking her. But we'll see here that that's not the one that ran, but this one, 34, that should be the one. But in either case, anytime you run your orchestrations, you do have a log here that you can go through. That's very good for debugging. It's very good for learning purposes of what is actually happening, and you can go through step by step of those particular tasks that are scheduled when the orchestrator is calling each activity function. So we'll just let that die like my social high school dreams. And we'll get rid of that. So async HTTP API, used potentially for very, very long-running things and when you want your client to be able to check on the status of that. And you can see the reason that this is so good with durable functions is that this is built into the library. You don't have to write the code to handle the long-running interactions. You don't have to create those endpoints. It's already there for you. It will take care of querying the orchestrator about the status, and it also manages the state, as we've seen in the Azure Storage account. So that's the async HTTP API. The next one is the monitor function. So the monitor pattern, excuse me. So the monitor pattern you can think of as the async, or a mirror of the async HTTP API pattern, where the async HTTP API pattern has a client constantly querying and checking on the status of what's going on with our orchestration. In this one, we have the orchestration pull a particular service to see what's going on, or at regular intervals, or to see if there's a particular state that has been met that we are keeping an eye on. So these are things that also can be long-running. These are things that are constantly asked, and these are things that we keep an eye out for. And this is very, very much in line with what my grandmother does. She always asks me where her grandchildren are. Ever since I have gotten married, it has been to this day, every 3 months, well, just about that time when she thinks it's long enough, she's going to ask me, hey, so where are those children? And I say, it's never going to happen. And we can see here an example of how we would implement that. So I have one called What Kids? And so here we have me. I'm her granddaughter, Adrienne. Ever since being married, there's this activity function that I'm going to call Ask About Kids that my grandmother has decided to invoke. She's going to implement the monitor pattern on me. We have a quarterly ask here. Around every 3 months, she's going to ask me, so where are those beautiful grandchildren? I deserve grandchildren. Where are my grandkids? And because this is a monitor pattern, this is going to continue indefinitely until some sort of expression is met that we have set. So in this case, one of those is, has it been 3 months yet? Has it been past our particular time where she usually asks me, hey, where are those kids? If it has timed out, we have a custom status here that we send, but essentially she's just going to ask me again. She's going to restart the process. We also have another state here that would also end this pattern, and that's if I actually got pregnant. I don't think that's ever going to happen. So we could have another function that constantly checks and says, hey, are you pregnant? Hey, do you have a bun in the oven? Hey, are you doing this? And if that is actually met, then this monitor function or monitor pattern wouldn't need to exist anymore. She wouldn't need to continue asking me because, oh, finally, she's going to get her grandkids. And that's what is stated here. And also, if it's right in between those times and she just is itching, maybe she's seen her other grandkids, or maybe she's seen her friends with grandkids and she's missing out, well, there's something here too, where if it's just not that time, like it's not the 3-month mark and it's not been expired, or I'm obviously not going to be pregnant, she's probably going to ask me in another 15 days, right around that breakpoint, 15-day intervals. So this is a very liberal interpretation of what I think the monitoring pattern is. And I did not do a full screen showing of that GIF. So the next pattern is human interaction. This is something that's very, very common. You have all done it yourselves already. If you have done any kind of two-factor authentication, that's an example of something like human interaction. Essentially, some workflows need human interaction. Shocking. And the next steps in our workflow are dependent on whether that person or that group or something does something or does not do something. We need that human to continue the process. So the other popular example of this is the approval workflow. Maybe it's for our pull requests whenever we have someone approve it and it goes to merge. We always need somebody to look at it first, unless you don't have any rules and it's the wild, wild west and you just merge your own PRs into your branches. Please don't do that. But in this particular work case, we have an example of that, and that's the approval workflow. So this is very, very common, and this is what you would do to kind of implement that in durable functions. So assuming we need to request an approval for something, say the GitHub request, we're going to use the foundling approved current UTC date time, and we're going to have a durable timeout, which creates a durable, or a durable timer that is safe for durable functions. And then all we have to do now is wait for some sort of approval event. So when somebody actually approves our pull request or denies it and it has passed a particular amount of time, then we can decide to do something. So if it's approved, then we can call another activity function where we write, whatever needs to be done to continue the process approval. So maybe that's merging our PR in. Or if the next process needs more comments, then the next step would be to escalate and send an email and say, hey, can you check out these comments? Or if no one looks at it, then maybe we just spam email them and say, look at my PR. But all of these things are the trigger for the next step in that human interaction pattern. So that is the human interaction pattern. And then the last one is fairly new. It has come about with the recent introduction of the entity functions. And that one is called the aggregator pattern. So the aggregator pattern is when you need to collect data over a bunch of resources or a variety of sources, or if you need to collect data over a long period of time. A good example is something maybe like your Fitbit or Google Fit that keeps track of your steps, keeps track of your heart rate, your weight if you log that, all that stuff, calories that you take, all of these things. They can come in batches, they can come in at different parts of the day, they can come in like, you're pretty good 1 week, 2 weeks straight, and then during the holidays kind of drops off, you don't get that information anymore. These are the kinds of things that that need the aggregator pattern because the way we grab our data is so varied. And what makes this difficult in regular Azure functions is that, well, how do you, again, correlate all of that data out of all of that period of time, out of the variety of resources? You can kind of piecemeal grab them. You can kind of say, okay, this came from this particular one, and this one came from this particular device, but that's very, very hard to keep track of. That's more code that you need to write. That's more mental overhead that you have to have in your head. And it's something that durable functions can give you and take a lot of that load off of you if you use a pattern like this. And that's the GIF I decided to use for aggregator function. So those are the 6 that I wanted to show you, and these are the 6 that are most commonly used when using durable functions. The most common ones that you've seen and have probably used are the human interaction ones, like I've mentioned, and the ones that are fairly easy to start using already are the function chaining and the fan-out, fan-in patterns, just because they are so close to the other task-based ways that we have written workflows before. But now by putting them in an orchestrator function, you can now leave all of that hard work to the durable functions library. And that's all I have, so thank you. And we have time, so if anybody has questions or wants to come talk to me after, I will be here.